Okay, good morning, and thank you very much for joining us. I see we have the participants coming in little by little. So as we let some people come in, I'll just deliver a few reminders to start with. First, I'm Rob Carlio from Trust IT Services and the DestinE Initiative. We're happy to organize this webinar in a series of webinars on the DestinE Platform services. So just a few reminders. So this is the SesamEO and DeltaTwin webinar. These are two DestinE Platform core services operated by GAEL Systems, and we'll hear a little bit more about that in a bit. Just a few housekeeping rules. So please remember that there is a dedicated Q&A segment at the end of this webinar. So my suggestion is if you have a question or a question pops up during a presentation, do leave it up until the end of a speaker's presentation, just in case your question is addressed in later slides. And if it's not, then just, feel free to plug it into the chat, and we'll make sure that that's covered during the Q&A segment. So in the meantime, if you want to test out the chat, just let us know where you're connecting from, say hi. That also allows us to see if the chat is working to receive your questions. So apart from that, before the start of this webinar, we actually have a little survey for you that we will launch shortly. That will be a poll, so please do participate in that. Now, okay, I see we have some participants still coming in, so welcome. Okay, so I think with that, yes, I see we have Dorothea, welcome, joining from Saarland in Germany, welcome, yeah, so I'd like to hear also from where else you're connecting from. In the meantime, I will already start to share a poll just to kick things off. So we have quite a few questions for you. So first is, how familiar are you with EO data? Also, which service provider or platform do you usually use to retrieve EO data? And also, how do you usually access or process this EO data? And what is your main challenge when retrieving EO data? So yes, please do participate. This would all be very useful for us later. Okay, so I think meanwhile, while people are filling this in, I suppose we can start with the introduction. So I'd like to call on Christophe Demange from GAEL Systems, who will provide an introduction to this organization and its two DestinE Platform core services, SesamEO and DeltaTwin. So Christophe, over to you.
Thank you, Rob. Good morning. So I'm sharing my screen. Yeah, you can see it.
Yes, that is showing.
Okay, Joe. So just first quick introduction about the company before to leave the floor to my colleagues. So GAEL Systems, a company we founded in 1990, and we are today 30 people in the team, located in France, in Paris area, and we have delivered more than 300 projects. So as important track records, we have managed tens of petabytes of EO data, and also created more than 1.4 billion product traces for recording product lifecycle events for ESA. So our main core business is based on EO data hubs, catalogs for fetching, ingesting, archiving, processing, and distributing data products. We also work with trusting data related to the quality control, traceability, and we have also, since more than 10 years, entered into cloud-native operations, so operating our solutions in the cloud for our customers. So as main products, we have data catalogs. So we have designed, implemented, maintained, and operated various solutions, such as the Data Hub services for several years before the actual data catalog for Copernicus ecosystem. We have still running other kind of catalogs for various customers. We built some image processing toolkits, data handling libraries, and also specified the set format for GISA. We have running quality control facilities in the ground segments, and more recently in the DestinE Platform core services will be presented by my colleagues. So yeah, the two main core services presented today are SesamEO and DeltaTwin. So one more based for data access bridge, and the other one for building collaborative components and run workflows that will be presented by my colleagues. So I was just quick to leave more time for the real presentation. Thank you. If you have any question further, I can answer. Sorry, I stop sharing the presentation. I leave the floor to Rosine.
Yeah.
Thank you.
Okay. Good morning, everyone. I'm Rosine Niemek. I'm the project manager for SesamEO project, and I will just introduce you to it. Let me just share my screen. Okay. So SesamEO is a data catalog, and projects are organized in teams and collections. As you can see, we have many collections for various providers. The providers are listed here. We have 8. Currently, we have 8 providers, and we can configure for some we need configuration, like climate data store, which need an API key for each user. So when you configure your providers, you have access to a various kind of data. And we have Sentinel, ERA 5, MODIS, and so on. For the next release, coming soon, next month, we have also the new climate change adaptation digital twin from ECMWF. So we have a user interface to interact with Sesam, and we have also an API. You can search collection by keywords, and now we check for Sentinel-2 MSC, for example. And it retrieves a set of collections matching my filters from various providers. And now I will select one of the collections, the L2A, and access a screen which allows us to filter products on this collection. And we see that we have 2 providers for this collection, CDSC and DGL, and we can filter using the date. In our case, we choose to filter products on from July 2025 to August of the same year. Okay, and you will also, you have the possibility to select an area of interest. We check in France, and we choose this bay, and we can filter by cloud cover also. And now we can run the search. If you want to use administrative information, you have the possibility to use the nuts, for example. It's easier way to select an area. And now you will retrieve all the products matching the filters, and you have also the number of products you retrieve. For a comfort to help the user, we create this feature to save the favorite, to save our search, our query, For example, I will call it a webinar, and also add a description. You retrieve here the filter you use for this request, and you can add it to your favorites. The favorites are listed here. When you browse your favorites, you retrieve all the products you saw previously. But it is not the result that is stored, it's just the request. Okay, so with the products you retrieve, you can see the details, the footprint, and other attributes. Okay, the other usage of Sesam is the API. This API is composed after you choose all the filters and you launch a request. So you can copy it with this button and use it in your scripts. And to perform this operation, you also need an API key. You can retrieve or generate it here in the account, the Sesam account. This is it helps us when we perform some automatic operations and you want to retrieve the products. And we will see a description of how we can use it with DeltaTwin. So I let the floor to Claire to talk us about this. Thank you.
Thank you, Rosine. So I'm Claire Billon, and I am the technical project manager for the DeltaTwin service. So let's share my screen. So what is DeltaTwin service? DeltaTwin is a collaborative workspace that lets you run a processing pipeline in a cloud environment without having to worry about the infrastructure behind them. So the principle is that you come with your code, wrap it into what we call a DeltaTwin component, or you can also reuse already existing pipeline shared by the community. You can run it, monitor their execution, and finally save and publish the generated result. So let's have a look to the web interface. You have basically two parts, your personal workspace and the public community workspace. In both sections, you have DeltaTwin it items, artifact items, and resource items. Resources are any data that you can upload in the service and that you can reuse later in your workflow. For example, here I have a GeoJSON file, and if I want to have details, you can see them by selecting the resource. Artifacts are also data, but they have been generated by your run inside the DeltaTwin service. So the key difference is that for the artifact, the service knows exactly how it has been generated. So now let's have a look to the DeltaTwin component. In the public gallery or in the starter kit gallery, you can find several types of DeltaTwin components. Some perform some basic common operation, like this one that crop a georeference image, or the band extractor that extracts a band from a Sentinel-2 product. You can run them directly or reuse them as a building blocks component into your own workflow. You also have, let's say, a more advanced DeltaTwin component. For example, this one aims to, they are designed for specific use case indeed. For example, this one aims to predict urban heat island over the city of Lisbon. So let's have a look into a DeltaTwin component. Each component comes with the descriptions that describes the purpose of the process. It also describes the inputs, the generated output, and you also have other technical information like the author, the license, topics that are basically keywords that categorize the process and that facilitate their search for using functionality search. You also have a version, meaning that you can update and improve your component over the time while keeping an history of its evolution. And the workflow view lets you explore the pipeline and the several steps. Here you have 3 kinds of nodes: the input nodes that are filled by the user, a models node, which refers to a processing, and the output nodes. In DeltaTwin, we have 2 other types of nodes, the resource node and the dependency node. Resource nodes are static parameters defined by the author of the DeltaTwin component. For example, it can refer to machine learning models that you have stored in your resource gallery. And dependency nodes refers to another DeltaTwin component because you can combine them. Then you can run your process. So I can select data. So here I will select a file with a 10 resolution, with a resolution of 10 meters. I can select a target resolution value, 40 meters. And if you want, you can schedule your run. You can choose to start it at a specific date and time, or run it periodically using a cron expression, for example, every minute. So once you start your run, you can monitor its progress. Here you can see that the service is reading the inputs value. All your runs are listed in these tabs. They are kept during 48 hours. So if you want to save the result of a previous run, you can access the generated outputs in the input and output tabs. And you can download them locally or save them as artifact, meaning that it will be enriched with some metadata. And some are automatically set by the service, but you can add some other information like the title, a description, topics, visibility status. And if you want, you can also use a smart data models templates, which are templates shared. It's open source templates shared by the Smart City community that aims to allow to describe your data using a universal way, and this promotes interoperability between services. At the end, your artifact, you will find your artifact in your artifact gallery. And that concludes my the overview of the DeltaTwin service. You can find further information in the online documentation available here. So you click user documentation. And now I will let my colleague Adam show you a concrete example of how to build DeltaTwin component by reusing another one.
Thank you, Claire. Hello, everyone. Like she said, I'm going to show you a concrete use case of DeltaTwin. First, I start by sharing my screen. And what I'm going to present you is a DeltaTwin component named post-fire detection. It is a component that is used to highlight burnt areas after a fire event. It is based on a tutorial by ESA, and it reuses other DeltaTwin component like bond extractor and resample image, for example. It calculates an index named normalized burnt ratio, NBR, and it also calculates this index between 2 Sentinel-2 scenes, one from before a fire event and one from after a fire event. And because the response from healthy vegetation and burnt areas differ, we can actually identify burnt areas. If the NBR value is close to 0 or even negative, it is most likely a healthy vegetation. And the more the index value is positive and higher, it is burnt area, and we have different severity levels based on the value of this index. This use case also outputs another file, which is a composite image, a false composite image that is composed of 3 bands that also further highlights the burnt areas. And we will go directly to DeltaTwin to show you how it presents. So the component is here. It has a description, and each component in DeltaTwin has inputs and outputs. Like we said, our inputs are 2 SesamEO products, one from before, one from after, and other input parameters are resolution. You can choose 1020 or 60. These are values possible from all SesamEO products, available in all SesamEO products. And you can also specify threshold for the SWIR bands. This allows to filter any water or shadow pixels, because if we don't want to calculate a fire index on these pixels. And also the NBR threshold, which allows to precisely filter pixels if we want a certain severity, only a certain severity, burn severity to be left. Our outputs, like I said, are NBR value in a raster format. We also have the composite image from 3 bands in also a raster format, and we have 2 histograms that we can also show and analyze later. So the workflow presents like this. We have the 2 SesamEO products that go into 2 bond extractor components. Each component extracts the bands, and they run into a resample image. So all the bands are either available in 10, 20, and some are only in 60 meters. So we have to resample them in the same resolution before calculating the indices. And the main process is here, which calculates all the indices, histograms, and so on. And you have the different outputs next. So in this case, we wanted to run this component on the odd region because there was a fire event in last summer, summer of 2025. So we went to SesamEO to find the products. We already did the research. We did a query. We found some products corresponding to that area and time horizon. So we just go to favorites directly to retrieve them back. Once we have the products, we identify, for example, 10 July 2025, that was before, and 11 August 2025, that was after. We copy each product. We go into the run section. We select SesamEO product. And if this is after or before, you paste the link here and you paste the API key. You do the same for the other product. And all the other parameters are filled with default values. So you just have to put the resolution and start on run. I'm not going to do it live because it takes some time. I am only going to show you the results. So once you have the results, they will be available in inputs and outputs section. You can either download or save them as artifact. And here they are. So we have for the region, we identified this area as a burnt area based on the NBR index that we calculated. And if we look at the composite image, we have the same area that is identified in magenta, and healthy vegetation is green. So it corresponds. The first histogram is the NBR at a pixel value at the pixel level. We have a peak at 0 that corresponds to the healthy vegetation, and it is the majority of the image. And we have this smaller peak here that corresponds to to the burnt pixels. So if we want to only keep this pixels, we can adjust our threshold. And this second histogram is the value, pixel value in the sphere band. We also use that in the post-processing step to filter. Pre-processing step to filter the water pixels. So we can adjust the threshold to get out this first peak that usually corresponds to water pixels. And next, so in order to have a component like this, there is a certain project presentation for each DeltaTwin component. So let's say you have your code in Python in your PyCharm or whatever. You want to make it as a DeltaTwin component. So you have to put your code under a folder named models. For each process you have a folder, dedicated folder. Here we have one process, which is post-fire detection. And then you have to specify two files, which are workflow.yml. This one contains and describes the nodes of the workflow and the edges, which are the links between the nodes. And the second file is manifest.json. This file holds all the metadata of your component, name, title, license, so on. Same for inputs. It has either type, description. For outputs, resources, which are just static inputs, so they have a static value. And for each of your models, you can, here it says you specify the type, only Python for now, its input and outputs, and you can also specify its hardware and software requirements in the parameters section. So here, for example, you can choose your how much CPU and RAM it needs to run into the cloud environment, and it's the libraries it needs to be installed alongside your code, and then everything is bundled in a Docker image that is run into the cloud environment with the command you specify and the arguments you put next to your command. And the last section is the dependencies, which are the other DeltaTwin components we used. So this was just a brief overview on how to construct a DeltaTwin and transform a use case into DeltaTwin component. And we also have a section in the documentation portal detailing on how to build a DeltaTwin, how to fill the manifest, and so on. You can refer to that. And once you have built your DeltaTwin, you can publish it to the service using our command line interface, CLI, which also is available in the documentation. And now I will let the floor to Benoit and our partners to present their use case.
Thank you.
Thank you. So, hello everyone, I'm Benoit Pironnet, Product Manager at GAEL Systems. I just want to mention that there are several resources available to help you to get started with our service. The documentation for our service is available directly on the DestinE Platform, video tutorials from the GAEL Systems YouTube channel, a GitLab repository with ready-to-use code example, and the DestinE public roadmap where you can follow upcoming features and share your ideas. And of course, if you have any question, don't hesitate to reach out directly. Our team is available at support@deltatwin.eu. Let's continue with the...
Sorry, Benoit, I think you're sharing the Zoom. Maybe you need to switch if you're... Okay, I think that's...
Sorry.
No worries.
Maybe it's better now.
It's still loading, and now that's good. Yes.
Okay. So let's continue with the concrete user example of our services. We are happy to have with us 3 contributors who will share their experience as user of the DeltaTwin and SesamEO services. I will now give the floor to Elena Magliaro, who will present the collaboration we have in the context of the TwinCity Marseille project. Elena, the floor is yours.
Thank you. Thank you. Can you hear me?
Yes.
Yes. Okay. Thank you. Hello, everyone, and thank you to be here. My name is Elena Magliaro, and today I will present co-design activities conducted around DestinE and Marseille TwinCity demonstrator. I will focus on the co-design methodology, the Marseille use case, and exploratory work toward operational and DVI workflows. Next slide. This work emerged from the collaboration between ESA DestinE program, two main Paris laboratories involved in the co-design work package, the Observation, Impact and Energy Center and Scientific Management Center, and the City of Marseille as an end-user partner. The objective was to develop a co-design methodology for climate services while exploring practical urban use cases with Marseille. Marseille was particularly interesting because of its climate-related challenges linked to heat, drought, and urban resilience. Next slide. This collaboration created an opportunity to connect Earth observation data with real urban climate changes. For Marseille, the objective was to better leverage environmental data to support urban resilience and decision-making. For DestinE, Marseille provided a concrete use case study to validate co-design approaches in a real urban context. It also helped demonstrate how Earth observation services could support future operational urban climate application. Next slide. Through this co-design journey, we structured the methodology around 5 main objectives. First, usefulness, understanding users and focusing on real operational problems. Second, operability, making sure services fit the existing platforms, data resources, and workflows. Third, usability, ensuring that services remain easy to use and support user adoption. And we also consider scalability and sustainability to make services reusable and maintainable over time. Overall, the objective was to progressively transform raw data and services into valuable operational services. Next slide. To support this methodology, we organized several co-design workshops with stakeholders from Marseille. The workshop relied on structured agendas, constructive discussion, and template, helping users formulate their needs. Close interaction between technical teams and operational stakeholders were particularly important throughout the process. These workshops helped us better understand operational context and identify more relevant urban climate service solutions. Next slide. One important workshop series focused on nature in the city strategies in Marseille. The objective was to co-design climate services supporting urban resilience and environmental management. Several operational topics were discussed, including drought warning situations, tree referencing, park and garden management, urban heat island effects, and vegetation monitoring. The workshops also helped structure exchanges between different user profiles, from operational teams to planning stakeholders. These discussions then lead to several co-design TwinCity use cases and analysis tools, such as drought assessment, vegetation index analysis, tree inventory exploration, and shading or sunlight evaluation for urban planning. Overall, the objective was to better understand how environmental indicators could support existing urban workflows and decision-making process while developing tools adapted to operational cities context. Next slide. TwinCity is available on the DestinE platform as an urban demonstrator based on the Marseille use case, integrating Earth observation data for urban climate analysis. Next slide. Next. The demonstrator combines several environmental data layers, including NDVI, surface temperature, moisture indicators, and urban contextual information. Users can spatially explore environmental dynamics across the city and combine multiple layers to better contextualize local situations. For example, vegetation indicators can be interpreted together with temperature patterns. This was particularly useful for discussions around vegetation stress, drought exposure, and urban heat islands effects. Next. Another important functionality was the possibility to define zone of interest directly within the demonstrator. Users could select parks, neighborhoods, or other urban areas and focus the analysis on localized situations. The localized exploration was particularly useful because operational stakeholders usually think in terms of neighborhoods, park, or specific intervention areas. This helped connect environmental indicators with concrete operational context. Next slide. The demonstration also allowed temporal exploration of environmental indicators. Users could analyze the evolution of NDVI together with surface temperature over time. This temporal dimension was particularly important because stakeholders were interested not only in static observation, but also in environmental evolution over time. Comparing NDVI and surface temperature helped explore possible relationship between vegetation dynamics and thermal behavior. This analysis supported discussions around urban resilience and long-term environmental monitoring. However, updates remain largely manual and difficult to operationalize continuously, which motivated exploratory discussion around automation workflows. Next slide. One key conclusion is that operational climate services require much more than visualization. They require continuously updated indicators, reliable workflows, and scalable data processing chains. In practice, operational service needs stable update workflows that remain reliable over time. The challenge is therefore to transform Earth observation data into operational services that can support day-to-day urban decision-making. Next slide. We therefore explored possible automation perspective with GAEL Systems and DeltaTwin workflows. The objective was to investigate whether workflow orchestration could support continuous NDVI updates and more reproducibly processing chains. Importantly, this was explored only as a perspective for future operational deployment and was not implemented in the current TwinCity demonstrator. This exploratory discussion, nevertheless, helped clarify the technical and operational conditions required for future scalability and operational continuity. Next slide. To conclude, I would highlight three main takeaways. First, co-design is essential to identify meaningful operational needs and connect environmental indicators with real decision-making context. Second, operational urban climate services require automation, reliable workflows, and continuously updated environmental indicator. And third, exploratory collaboration around workflow orchestration can help identify possible pathways towards more sustainable operational services. Thank you very much for your attention, and I'm happy to take questions later. Thank you.
Thank you, Elena, for sharing your experience with this urban twin project and the DestinE ecosystem. Next, Maximilian Schwartz from Remote Sensing Solution will tell us about the EOAgriTwin project, which explore agricultural application within the DestinE framework. Maximilian, the floor is yours.
Hello, everybody, also from my side. Thank you for the nice introduction. As Benoit said, I will give a quick introduction to the EOAgriTwin project and how we use the service DeltaTwin. So first of all, the project is about building a digital twin for agriculture under multiple stresses, and we try to support the monitoring of crop condition, simulation of growth dynamics, and the production under different conditions and stress factors. And to do so, we're focusing on 4 thematic points, which is drought and heat stress impact monitoring and modeling, pest and disease assessment, drought impact under different management, like for example, irrigation, and the impact of stresses on yield resilience and sustainability. We have 4 use cases. 2 of them are located in Germany. One of them is in Italy and one of them is in Kenya. The different use cases are listed in the top right. And within those use cases, we try to answer different what-if scenarios or different questions, like, for example, what if droughts become more intense in the future? What if heat waves occur earlier? What if irrigation is applied? And also, what if rainfall patterns and dry spells affect disease spread and yield? And all of that is built around stakeholder needs and feedback that we gather through questionnaires and webinars. And this feedback directly feeds the development of our digital twin. The digital twin component that we're building has a few components on the left side, starting with mainly EO data and then some field data on yield, irrigation, management, or also pests and diseases. And then we have different models. On one hand, we work with data-driven models like machine learning models or AI models. And then on the other hand, with process-based models, for example, for yield estimates. And then in the next step, what's following is impact assessment and the validation and uncertainty assessment. And all the results are then visualized in a dashboard where the users can interact with our data sets. And now basically these components are then transferred to the DestinE environment. So first on the left-hand side, you have our data access, which is mainly the DestinE data lake and the Copernicus data space ecosystems for the different Sentinel satellites, but also for other Copernicus data sets like the land cover or RF5 data. And we access these data sets through SesamEO, for example, but also through HDA, which is the harmonized data access. And then we also use the Polytope service, for example, to access data from the climate digital twin. After accessing the data, we then have our different processing components in DeltaTwin, like explained earlier, basically. So first we have different pre-processing pipelines, like here, for example, visualize for Sentinel-3, where we pre-process the data and then compute LST, NDVI, or NDII, and then build our in-project stack catalog, which then feeds our different modules or DeltaTwin components. All our DeltaTwin components are basically model applications, so it's basically inference. The models are trained outside of DeltaTwin, and then the final DeltaTwin components just reflect the model application. And then each module here would represent different outputs, like, for example, a drought model or field delineation based on AI. So different kinds of models that produce all different kinds of outputs, like, for example, in cloud optimized GeoTIFF format, in vector format, but also in tables. And these outputs are then exported from DeltaTwin to the OVH cloud, where then our visualization dashboard is hosted. That is then connected to the users. I just have one small example here now, a very basic workflow, a little bit easier than the other ones shown previously, for our drought probability model. So basically all the model inference is in the drought probability framework here, and the only input that's needed is start and end year and start and end month, which basically then, if that's put in the workflow, automatically triggers the data collection and then the model application. And after our run, even though it looks quite easy here, it's a little bit more complicated in the background, would trigger some results that you can see here, for example, which are monthly drought hazard maps for our 3 study sites in Germany, Italy, and Kenya. And yeah, so that's basically the overview of the project and how we use DeltaTwin. And I have one final slide where we as users can also give some feedback, so that maybe people that have not used DeltaTwin know a little bit more what to expect. Basically, everything is super user-friendly, and you have access for different programming skill levels, like, for example, the workflow and user interface that was shown before, but you can also work with the APIs. It's very easy to transfer your existing algorithms due to the available Docker environment. There's, on the other hand, not super much flexibility since custom Docker files are not supported due to security reasons within the DestinE environment. There is a tenancy concept which allows you to work as a group together and have increased usage possibilities. It's very easy to connect to other services. That was also shown before, but that works also through APIs. The download capabilities that have been shown, so it's quite easy to export data to, I don't know, where your platform lies, or just download to your computer. In the beginning, the component definition is a little bit complicated, but when you've done it once, it gets quite easy, and running it is also very simple. And currently, it's only supporting Python, but we were told that will be also changed, for example, to R. And maybe one additional feedback from our side as users, if you have any feedback to GAEL, they're happy to work with you together on solutions that are maybe needed. So for us right now, we're very happy to work with DeltaTwin and SesamEO. So yeah, that would be the feedback from our side. But we're also happy if you would check out our project homepage or our dashboard, or get in contact with us if you want any more information from our side. Thank you very much.
Thank you, Maximilian, for sharing this EOAgriTwin project activity within DestinE and the feedback about our services. Finally, David Purnell from Serco will present work on fire risk assessment, a component shared with the DestinE community. David, over to you.
Hi everyone. Yeah, so I'll just share my screen. Okay. Yeah, so my name's David Purnell. I'm a software integration engineer at Serco, and I work on Earth observation projects, including the DestinE platform. And so I'll give an overview of my work within DeltaTwin, creating reusable components. I'll give an overview of what I've done, my methodology for creating different components, and a quick demo on the interface as well. So my motivation for using DeltaTwin was to create reusable DestinE data access workflows for visualizing and processing different kinds of DestinE data. And I worked on 3 different components so far in different topics. So as Benoit mentioned, in fire monitoring, and also one component more based on urban heat island. One of these is published, and the other 2 so available publicly, and the other 2 are in preparation. And the key features of these components I've listed here. So Python-based, which is a requirement for now. Another thing that I think will be potentially useful for the community is the integration with the harmonized data access service, which Maximilian mentioned. And this is the DestinE data lake. Another thing I'd like to highlight is that these components I've worked on, the code is available publicly. You can see the link here, so that might be useful as additional examples for the community. And you can see here on the right 2 of the outputs from these components that I've worked on. So at the top a fire weather index forecast, and at the bottom a land surface temperature analysis from Landsat. And here is my kind of basic workflow for working on these components. So first step is kind of like any Python Earth observation project. So gathering dependencies, which data sources to use, and processing and plotting data. And then the second step is the component testing. So really packaging your Python code so that it can be used with DeltaTwin. So that's, as other speakers have talked about, defining the inputs and outputs, and a lot of time working on these key files, so the manifest.json and the workflow file, and then using the DeltaTwin CLI to test locally before publishing the component on the interface. And for this step 2, I do want to mention the examples on the GAEL GitLab that were really useful for building my own components. And the final step is to publish and test on the interface. I also put in some effort to make some detailed documentation. As I said, the code is available, and so yeah, please go ahead and have a look at that if you're interested. And with that, we can have a quick look at DeltaTwin components I've worked on. Hopefully I'm still signed in here. So first one I will show is the publicly available one, which you can find here. It's one from Circo. That's Fire Risk Plotter. And if we go to run this component, it's a bit different from the other ones because you're required to, well, firstly, it's a very limited component. All you're asked to do is provide your credentials. This is because of the integration with the HTA service. And then I will just quickly show one of the not yet public components that I've been working on. So this is the LST plotter, which is also integrated with the HTA service. So as you can see, you're required to input username and password, but also to provide a city and a date. And I'll just show what the workflow looks like. So here are the credentials and other inputs. And for outputs, we have a PNG image and also a raster. And here is one run I did yesterday. We can just have a quick look at the output. And this should be, yes, an example over Naples, which looks maybe too hot, I think, for this time of year. I'm not sure if that's a good good estimation of the temperature, but anyway, just as an example of the output. And that's all I have.
Thank you, David. Thank you so much to all our speakers for this rich and inspiring presentation. We warmly invite you to explore these services, join the community, and reach out to us if you have any question or project ideas. Our team is here to support you. Thank you all for your attention. So I think we can now move to the Q&A session.
Indeed. Excellent. Thank you very much, everyone, for your presentations. As I mentioned to the participants, so you are free to type in your questions in the chat and we'll pick that up. I invite also our panelists to please join me and activate your cameras so that our attendees can see you. In the meantime, maybe it might be a good idea just to buy some time, have a look at the survey that we ran from the beginning of the webinar. So I see in terms of our participants' familiarity with EO data, so let's say about half of our participants do work with EO data regularly, and also about half are more on the, let's say, basic side. So some are saying that they're new to EO data or are at least familiar with the basics. Now, as for which service provider or platform do we usually use to retrieve EO data? Oh, let me just close the poll so we can share the results as well. Oh, sorry. Okay. Let's see the details. Okay, so we have some participants that use DestinE. Someone mentioned Copernicus browser and Alaska satellite facility. Someone also mentions working with DWD. So if I do need to access EO data, okay, so you can access colleagues. I guess it's a person from DWD. Someone mentions Wikio, CDSE, and C3S Global Land Service. On the question on how to usually access or process EO data, about half are actually saying that they currently do not access or process, and about a little more than a third are saying they access mostly through a user interface, and one mentions through both user interfaces and programming. And one of the last questions, what is your main challenge when retrieving EO data? So I'll start with the most. 25% say it's actually finding the right data sets, and others as well. Let me see if it's here. Yeah, and the others, user engagement mechanisms and how these affect the data to implement the value chain. And also, someone mentions actually they don't have any challenges with it at all. And then evenly distributed among the others, it's accessing or downloading data efficiently, understanding data formats or metadata, preparing data for analysis, and integrating data into workflows. So that's the result of the poll. Let me see, there is a couple of questions that we received in the chat. So one, can DeltaTwin be mobilized for education purposes? So students projects seeking to increase awareness on climate data, cloud computing, Python. Are there any activities in this direction? Anyone who would like to address that from our panelists?
Maybe I can answer, yes.
Go ahead.
The answer would be yes, of course. This is a typical good playground for education, where the different registered users, so including students, could try accessing wide possibilities of data sets from climate data, Earth observation, and practice easily cloud computing because it's handled in the background, and use Python as a model. So yes, I would say typically a good use case for that. And we have some tracks to follow in this direction, yes, with some schools around us, for instance. But if you have, Nicolas, asking the question, if you have already things in mind, we can discuss it, of course.
Yes. Okay, thank you very much. I see that we also...
Yeah, maybe just to add an additional point, we have on public GitLab tutorials, so it's also part of the resources available to understand how to use the service, and a kind of progressive skills from simple hello world to more complex models through the various tutorial samples.
Okay, very good. Another question received. I understand that for now only Python is supported, but do you plan to support other programming languages in the future, for example, R?
Yeah. Would you like to answer, Claire?
Yes, I can. Sorry, but it seems that my camera is not working anymore. But yes, in the next version, we want to enlarge the supporting language and to have to support R and the other language. In this way, we will change our also our way to construct a DeltaTwin component by using the command working language template. And in this way, you will be able to bring your own Docker image, and so that it will be built in every language that you want, and it will allow to and not be restricted to Python language and in the future. So it will be console.
Okay. Thank you. As we are coming up to the hour, so we just have one question left. Does the DeltaTwin service give access to resources like GPUs? If yes, can you explain whether there will be quotas?
Yes, effectively, we currently there is no CPU functionality, but we are preparing this, and it will come. I think during the summer, you will be able to target a specific step of your pipeline to run on the GPU resources, and I also underline that. In the free tier, you are currently able to run up to 10 runs, and we will update this metrics usage so that user will be allowed to user to benefit from the infrastructure resources during a certain period of time, and we will take into account the memory, the CPU usage, and also the GPU usage.
Very good. Now, if there's nothing else, I'm afraid we've come up to the deadline of our webinar. So I think we can close here. But before we do that, I'd like to thank everyone, especially our participants, for staying on with us throughout the entire hour. Thank you very much for joining us. The DestinE Platform has an active schedule of webinars, so this won't be the last. So stay tuned. We will have quite a few more webinars lined up for you that will be announced soon. So just make sure you stay in touch, stay tuned. We have a few more services we would like to share with you. And if you will be joining us in the DestinE User Exchange, be sure to say hi and come over and greet us. We'd be happy to meet you there. Now, I think that's all for us. So thank you very much, everyone, for those in Europe. So have a nice lunch.
Thank you.
See you. Bye.
Bye.
Bye. Bye.
Bye.